And definitely looking forward to our next guest. We are going to be having Denis Jannot, Director of Field Engineering at Solo.io. Welcome, Denis.
Hey, nice to meet you.
Nice to meet you as well. And today, I know I'm looking forward to hearing about this. We're talking about the challenges of exposing and connecting microservices.
Yeah.
Awesome. And as a reminder for everyone, please put in your questions in the chat so we can definitely go over them during the Q&A at the end. And looking forward to this, Denny. Thank you.
Thank you, Jen. So, welcome everyone. I think Jen already introduced the topic, so I think I'm going to skip these two slides, right? I'm taking care of the field engineering team in EMEA at Solo.io. We are hiring, so don't hesitate to ping me if you're want to work with us at Solo. We'll be very happy to have you on board. Um, Really, like, starting quickly, obviously everyone knows that we go from monolith to microservices, and that these microservices tend to run on Kubernetes today, so nothing really new there. But what I want to go through is, like, what are the main challenges that you get when you want to expose these services to outside securely, and also when you want to connect them securely, right? So these are like the two main topics, and you will see that these two topics are quite well related one with another. So let's start with the first one, right? How we expose these applications. It's a natural way if I run my services on Kubernetes is to use like an ingress controller like Nginx or HA proxy, for example. And that does the job, right? You can expose your services securely. I mean, like exposing with like HTTPS, for example, right? And you can do some basic routing, right? But not much, right? Um, and what happens is that you start to deploy more and more services there, right? And you start to implement some security mechanism directly in your application. For example, let's say you have a web UI, right? And you want to expose it outside, and you want to authenticate your users with OIDC workflow, for example. Then you will have to implement that directly in your application. If you want to expose your API and you want people to consume this API with API keys, exactly the same, right? You would have to do that in your application. The same if you want to secure that with Joe tokens and so on, right? And it's like some of these security mechanism, you will have to implement them in the application, and some of them you will have to implement them outside of the cluster. Like typically, if you want to protect your APIs with rate limiting or with web application firewall, right? You will generally do that outside of the cluster. So here you have like two main challenges, right? Or even more than that, right? So the first one is that the application team, instead of focusing on the business logic, they spend time to implement all these authentication mechanism. And the second problem, I would say, is that if the security team wants to know what's going on, how my different APIs or UIs are secured, they don't know, right? They have to talk to all these different teams. And I would say the last problem is when this team wants to secure their API with rate limiting or things like that, right? They need to contact another team responsible for this API gateway to make it happen, right? So instead of doing this, right, a new pattern we see is really to adopt like a Kubernetes native API gateway. What we mean by Kubernetes native is that you want an API gateway that you can configure 100% through Kubernetes objects, through YAML, right? So why you want that? Because you want the application team to focus on the business logic. You don't want them to implement the authentication logic in their code, but you still want them to be able to determine how they want to secure their APIs or applications, right? So if you have something like Kubernetes native, then the same way they decide how to deploy application by providing YAML, through a CI/CD pipeline, they can provide the YAML that correspond to the way they want to authenticate the user, right? And that means that they don't have to manage the complexity, but they can still drive the configuration. And what's nice also with this kind of API gateway is that you can generally also have this rate limiting WAF and other capability that you generally had before with, outside of the cluster. So now they can also configure these additional security mechanism as code, right? And the last benefits you get is now the security team wants to know what's going on. They can just go to this API gateway configuration and have a look at how everything has been configured, how everything has been secured. That's not because you deploy this API gateway on Kubernetes that you can only use it to expose services running on Kubernetes. You can use it to expose services running in VMs, in Lambda functions, and so on. Right? That's completely possible. So again, we discussed about that. It's GitOps friendly, everything as code. The application focus on the business logic, and the security team gets visibility. So that's about how you securely expose your services. But then what happens is that you still have no control on how the microservices inside your clusters are communicating together. You don't have visibility. You don't really know if it's secured or not. And if services, wants to communicate together with encryption, for example, they need to agree about how to do that, right? And that's a lot of complexity, again, that needs to be managed by the application team instead of focusing on the business logic. So the idea here is that the service mesh is here to solve this problem. So with the service mesh, what do? You have this proxy that sits in the middle between the client and the server, right? So this proxy is intercepting the request and is able to implement some of this feature that we described. Like if I want to have encryption between service A and B, I can delegate that to the service mesh. If I want to know what's going on, I will be able to know that because this proxy will generate some telemetry data that will allow us to build graphs and know exactly which service talk together. It's not limited to Kubernetes. Again, you can extend your mesh with VMs or bare metal servers. You can talk to external services and so on, right? But again, the benefit is the same as what we described before. Like application team can focus on their application, the business logic, right? And they can delegate the other, security or observability concern to the platform. And they can still have control on it because, again, you can drive everything as code, right? When you start to have like multiple clusters, it's more involved, right? So what happens is that, let's say you start with one Kubernetes cluster because, you have a limited number of microservices. And then you start to have either more and more services and you don't want to have like one very large cluster because you don't want, like when you do an upgrade, to have a higher risk, right? Or you have multiple data centers, or you want to have some services on premise and some in the cloud, right? And you want these services needs to talk together sometime, right? Because you can have like a shared service that is accessed by a lot of other microservices. Or you can have a service running in one cluster right now, but tomorrow you want to move this service to another cluster because the team that is in charge of this service, they want to go to another data center or another cloud or whatever. So all these things are possible with a service mesh, but it becomes more difficult to configure, maintain this kind of configuration. And if we take the example of Istio, right, which is the most popular service mesh, you can see that you have this control plane component, which is Istio-D at the bottom. You have this envoy proxy that is this proxy that sits between the services, allowing you to get control about how these services talk together. And you also have this Istio gateway that you can use for ingress or for egress. And the reason why I highlight this is that if I adopt a service mesh like Istio, it still doesn't really solve my connection problem, because I said before, if you have like a standard ingress, you cannot do much. You need a proper API gateway. And the Istio gateway is not a proper API gateway. It's not like an advanced enterprise gateway that provides like WAF and OIDC and all these things, right? It's pretty basic API gateway that mostly provide routing, right? So we are going to explain now, like, how we help customers like solving these problems with a unique platform. So the idea, and this is our end goal, right? So we are like expert in application networking. What do we mean by application networking? What we want is that you deploy microservices anywhere. Like you decide which Kubernetes platform you want to use. Like it can be on premise, your own Kubernetes cluster, or like something like running on OpenShift, or it can be EKS or GKE or whatever platform, right? You deploy your services there, and you want to be able to manage how these services communicate together, even if they are on different clusters. And you want to be able to secure some of this communication to get visibility, and you also want to expose some of these services outside. And again, with security, right? With authentication, WAF, and so on, right? So that's the idea. We want you to feel that this is one large, mesh, or one large environment that you can manage very easily, right? And the way we do it is that we have this glue mesh software that you deployed either in a dedicated management cluster, but can be also one of the cluster where you're an Istio. And this management plane sits on top of multiple clusters where you have Istio deployed. And it provides an higher level API, so new Kubernetes CRDs, right, that are global. What I mean by global is that they are aware of all these clusters. It's, if you deploy like a service mesh, like you deploy Istio in cluster 1, all the things you configure are in this context of this cluster, right? But here, this management plate sits on top of all these clusters. So I can use an API that can tell I want this service on this cluster to be able to talk to this service on this cluster, for example. And we build this API in a way that it match really well the personas, right? So basically, if you look at Istio virtual services, for example, you can use it for routing, but you can also use it for like setting timeout, for example, right? These are two different things. But if I grant a user the ability to create virtual services, I cannot limit them to only manage routing. So what we did in GlueMesh is really having this API where you have one object for each purpose, like a route table for routing, a timeout, retry and timeout policy for these timeouts, and so on, right? And I'm going to show you that quickly, so that will make more sense. And also we have embedded like the multi-tenancy in it, so I think it's quite interesting. If you subscribe to this offering, you also get like end-to-end Istio support from us for N-4 version. That means that we are going to backport all the CVEs and all these kind of things. We can provide like some FIPS compliant Istio. We help you, adopting Istio, maintaining it. You get your own private Slack channel. You can interact with our experts in a very natural way with a really good response from us, right? But the most important is going through the demo so that you get a better idea about what I mean by all these things. So here, what I have is that I have like two clusters, right, where I have the book info application deployed. You are probably familiar with it. It's like the most popular application that people use when they play with Istio that has multiple microservices. You see the product page here that talk to the reviews, and the reviews talk to ratings, and product page also talk to details. And you see here on cluster 1 here, I have the V1 and V2 of reviews, and here I have the same, but I have V3 as well, right? And I have my management plane there at the bottom, right? So all these services are running there, right? And I have these namespaces, right? So I have like the product page service in a Bookinfo front-end namespace and the Bookinfo backend in namespace that gets these three other microservices. So the first thing that is really nice in this GlueMesh API is the ability to define what we call a workspace. So you can have like a Bookinfo workspace. So the platform team will say, okay, I want the Bookinfo team to be able to have their own workspace, which will be composed of these Bookinfo frontend and backend namespaces on cluster 1 and on cluster 2. Right? It could be only one namespace of one cluster. It could be different namespaces in different clusters. It doesn't matter. So you give this workspace to this team, and then this team can define using a workspace settings that they create in one of their namespace. They can define which services they want to export or import from other workspaces. So let's say I have 10 services, or in this example, let's say I have like my front end is the product page, and I want like the gateway team to be able to access the product page, to be able to expose it, right? Then I will be able to do that without having to expose my other services. The other benefits you get with this workspace is that if you want to implement zero trust in Istio, you have these authorization policies that you can create to say, I want service A to be able to talk to service B, but not to service C, and so on. That can be quite tricky to maintain, hundreds of rules, right? But now that we have this boundary, we can simply enable service isolation here, and it will automatically tell GlueMesh to translate that into all these Istio authorization policies. So what I didn't mention is that everything you do here with this API will be translated by GlueMesh in the corresponding Istio configuration. Now let's speak about the connecting challenge, and then we'll go quickly to the exposing challenge, right? So the connecting challenge, one of the things that is quite nice is this ability to create what we call like virtual destinations. So let me just go there, and I can, let me just go to this another here. So I can basically create a virtual destination that say it will be this name product page.global, and will be composed of all my product page services running across my clusters. So the benefit is that the consumer now doesn't need to know where the service is. They don't send requests to the local product page. They just send requests to the product page service. And they will do that with a route table. They can define they want to send a request to this virtual destination. So it's very nice because now that it's a virtual destination, basically it means that the producer, the Bookinfo team, they can decide to move this service to another cluster and it will still work, right? And you can also like enable like, some policies to define like I want to first use the local version of the product page if I can find one, and if I cannot, or if the local one doesn't respond, I want to automatically fail over. And you can see all these policies that you create, they will be selected based on labels. So this policy will select all the virtual destination that have the label failover equal true, right? So I just need to update my virtual destination with this label, and automatically now it's going to go through it, right? So if I go here on my first cluster, it's going to be served by cluster 1. If I go to my second cluster, it's served by cluster 2, so it's always served by the local one, right? But imagine I have a failure and I can simulate that failure by just like patching my product page on the first cluster to make it unavailable. Then automatically now request on the first cluster will be redirected to cluster 2. You can see it here, right? So it's really nice, right? You get local first, but automatic failover. So that's for the exposing things, right? Now, if we go to the securing things, I told you that the Istio Ingress Gateway doesn't really do much, right? It's just routing. But the good news is that we have added the ability to transform this Istio Ingress Gateway. We don't replace it, we transform it so that it gets all these nice enterprise features like authentication, WAF, and so on, right? So what we do is that we create like a xDot policy. We want to authenticate all the routes that have this label here with a key cloak, right? And here it's like a OIDC workflow. And now if I update my root table here and I say I have this label OAuth equal true, then automatically if I try to access this other page here, I will be redirected to Keycloak here, right? So let me, oh, I didn't put get, sorry. So I'm directly redirected to Keycloak. And if I log in, I can even see that we have done some, good stuff. We can extract, after we authenticated the user, we can extract information like the email claim. We transform it in the X email header so that the backend application knows, who is the user that have been authenticated. We do that with, what we call a JOD policy. Like here, we see like we extract some claim. We can then transform the claim to create a new header, based on a regular expression. We can apply rate limiting that is now based on this secured header that came from the JOD token. We can apply, WAF and all these things, right? So I think I'm already just in time. So I'm going to stop here and ask Jen if there are any questions.
Thank you, Denny, for your presentation. Definitely appreciate it. There is one question that came up. Are users generally adopting first an API gateway or service mesh?
Yeah, that's a good question. I mean, it really depends. There is no rule for that, right? In the past, I would say probably API gateways have been adopted before service mesh, right? But now we see like all kind of adoption patterns. Some start with the service mesh because they won't get visibility on their services. Perhaps they don't develop a lot of new services, so they already have authentication there. They don't want to rewrite them, right? Some do the opposite. They want to start with an API gateway, but they also understand that there is this problem of, connectivity of services. So that's why we kind of build all these things in one platform now. So that if you are interested by the API gateway first, instead of starting by an API gateway that has nothing to do with Istio and then having to deploy Istio and look at how to integrate all these things together, you can start with our platform and just use the API gateway. And to use the service mesh later, you will just have to start to enable it, right? So that will be a lot easier in terms of adoption.
Great, thank you. And also, just to go over it again, where can we find out more information about all of this?
I mean, like there are a few things, right? We have like the solo.io, website where you can go to the events page. There, you will see that we do a lot of workshops. We do workshops where we want to educate people on technologies like Istio or eBPF or Cilium, purely open source, right? Nothing to do with really our product. And then we do our product workshop where you can learn about Glue Mesh Gateway, all these things, right? So they are quite popular workshop. We deliver that every week. We do a different workshop in different time zone. We do like EMEA, in APAC, in the US, right? So that's a really good way to learn more about our products. And then you can interact with us on Slack, right? We have our public Slack that is really popular, and you can just ping me there or any of my team and start to ask questions.
Wonderful, thank you. And I can only imagine how important it is to be a part of that community to get these questions answered and also share the knowledge. Now, that is it that we had for today. And thank you so much for working with us and being here today.
Bye-bye.